Now that we have written the code for binary search, let's look at some cases of interest to see how exactly it works in the different scenarios. In fact, we'll start with the same 5 cases that we did, for example, for the jump search. Remember, the cases were the search item at the jump positions, the search item in the list but not at the jump position, search item in the range but not in the list, search item larger than the largest value and smaller than the smallest value. Of course, 4 and 5, like we discussed, could be solved trivially, but we let the algorithm sort of solve them. Yeah. Now, this is a little bit off, but basically what I mean is that cases number 1 and 2 in this case, we will analyze together as a single case, which is that item is in the list because there is no notion of jump values and jump positions over here. So we are going to basically analyze 4 cases. First is these two, which is item in the list, then item not in the list but in the range. Then the 4 and 5, which is item larger than the largest value, item smaller than the smallest value. So let's start with the first one. Item is in the list. Now here I've created a very simple illustration just to sort of see how the pointers move. And then later on we'll see this in the code by putting some print statement. So just kind of validate this intuition on a slightly larger list. Let's say we have a list of 17 items, so 0 until 16. Remember, when the code starts, we set the pointers to be 0 for the low and 16 for L, for the high, sorry. So basically the pointers are here and we go and search in the middle. That's my mid value. That is in fact given by 0 plus 16 floor division 2, which is indeed 8. Now I am looking for this orange value, which happens to be 6 in this case, or item 6 in the list. Remember, the list is sorted. So when I do this first search, I'm going to find that, look, my mid is larger than the search value. So I move my high pointer here. Now again, remember, however, we always search on the middle. So middle in this case will be 0 plus 7 floor division 2, that is 3. So I search here. I find that my search value is now more than the mid value. So I move my pointer to mid plus 1. So now this is my low pointer, this is my high pointer. Remember, however, we are always searching on the middle, which means I do one more iteration to search at 5. Remember, 4 plus 7 is 11. Floor division 2 is 5. I search here. I find that my value being searched is more than the middle value. So hence I move my low pointer to mid plus 1. It turns out that my mid pointer goes and hits exactly that value that I was looking for, and hence the item is found. So that's the condition. That's the condition where the item is in the list. Now you can basically extend this argument to argue that, look, no matter where the item is in the list, it will be found because the mid pointer eventually will go and hit this value. Remember, the mid pointer must reach that value because it's at the mid that we are searching. It's not the low and high. It's in fact at the mid, right? So basically code terminates and the mid index becomes equal to the item index. Now, in order to understand the behavior of this code better, I'm printing low, mid, and high in this statement. So I first print low, then the high, and then the mid, because mid is derived from high and low. Now, mind you, this print statement has to be after this mid has been assigned, otherwise there'll be an error. So anyway, now to see this in action, I ran this code with a search value of 43. Remember, my list was 0 to 100. That means the length is 100. So I start with 0 and 99. My mid is 49. Remember, mid is where I search. In this case, the value being searched is smaller than the mid, which means that my high pointer must move to 48. Remember, mid minus 1. Then I go and search 24. 24 is smaller than 43, which means my low pointer becomes 25. High stays there. Mid happens to be 36. I search at 36. 36 is lower than this value. So again, low pointer move 37, then 43. At this point, I'm searching at 45, which is indeed higher. So my high pointer moves back. I find that my low and high have become 33 and 43 and 44 respectively. The mid as a result is 43. And indeed, I get the value. Go through it slowly. It will make a lot of sense. Let's look at the case number 2, which is a situation where the item is in the range but not in the list. For example, let's say between 10 and 11 of this list. I start searching low and high as setup. I search at 8. Well, the moment I search at 8, I know that the item is not on the left half, which means my low moves to mid plus 1. This time around, I find that the item being searched is smaller than the mid value, which happens to be 12 here. So I move my high pointer to mid minus 1. So now notice this is a low, this is high. I search in the middle of the two. Now it turns out that the search value is smaller than the let's say the orange value. So which means my low pointer will move here. Now at this point, you will find that the search value, which is the orange value, is smaller than the the mid value, right? So which means that my high pointer will move backwards. there is an inversion happening. At the moment inversion happens, I in fact exit the loop, declaring that the item has not been found. So again, you can argue that if the item is in the range but not in the list, you will always have an inversion, and the list will the loop will in fact exit. Let's see this from the code. So for instance, let's say I run the same code for a search of, let's say, 21.5, just taking a different number. Now notice 21.5 is in the range, but definitely not in the list, because list has all integers here. When I run this, something interesting happens here. Notice I start with 0.99, mid is 49, I search at 49, I go further, so high becomes 48, high becomes 23. So notice initially only the high is moving. Then I go to, for example, I search at mid of 11. Now this is where low has started to move. So low becomes, let's say, mid plus 1. I search at 17, low becomes 18. I search at 20, low becomes 21. I search at 22, low becomes, so I search at 22, which is the time where the value has become more than 21.5, which means high becomes less than the low pointer. I mean, high becomes equal to, let's say, the low pointer, but then the loop exits, because remember, in this situation, as I have not found it, I'm going to have a situation where x is less than L mid. Remember, my value being searched is at 21, whereas the value is 25, 21.5. So I'll be in this situation, high will become mid minus 1. And the moment that happens, in fact, the loop will actually exit, because remember, the inversion of pointers has happened here, right? So inversion of pointers is exactly what's going on here. You can imagine that just after this, the inversion happens, and in fact, the loop stops. So very carefully go through this. Very interesting to understand how this is working. Now let's move to the third case, which is the situation where the value being searched is larger than the largest value. Now again, this could have been trivially handled, but never mind. Let's see how the loop responds to this. Quite interesting to understand how the pointers are moving. Basically, I start with low and high. Mid is here. I know that the value is far to the right, so essentially I'm just going to be moving. I'm going to be just moving my left left pointer, which will be always becoming mid plus one. So it becomes mid plus one here, mid plus one here, mid plus one here. At some point, they all become equal. Now remember, at this point, the value being searched is, let's say, 100. Let's say outside the list, which means the mid value is in fact smaller than the value being searched, right? So x is actually greater than this value, which means low will become larger, and again there's an inversion of pointers, and hence the loop will stop. Now this is like the case that I've drawn here. Notice at some point all of them become equal, but at this point the value where we are searching is 99, but the value that we were looking for is 120, which means that the low will become mid plus 1, which is 100, and the moment this inversion happens, low becomes more than high, the loop gets over. Now why does low become more than high? Well, because remember this condition, right? We are not going into the if here, we are coming into the else, because x is say 120, whereas L mid is say 99, right? So I come into low is equal to mid plus 1. Point is inversion happens, and hence the while loop exits, and hence we know the item is not in the list. Finally, the fourth condition, so the value is smaller than the smallest. So again, I keep moving my high pointer leftward, so I keep coming down. At some point, they all become equal. But here's a situation where x is indeed less than L mid, which means high is going to go further left, and again there'll be an inversion of pointers, and hence I will find that the item is not available. I don't know. This seems wrong, right? So we just have to focus here. So this declare not found. I run this case in the longer list that I have. The pointers, behave a little bit differently, but the idea is the same. Notice at some point low is 0, high is 1, and mid is 0. I search in the mid. Clearly, the value being searched, x, is less than L mid, which means high is going to move less than the mid, which means high will become minus 1, low is 0. Once again, to summarize the operation, basically we saw that the loop runs while this condition is true. We have seen this before, which means loop terminates in one of these conditions. Either the item is found, which happens if L mid is equal to x, or low becomes greater than high, which means the pointers invert. And this happens when the item is not in the list. So this is how the whole code is coming together. Like I said, think through carefully, work through your own examples, because that is how you'll get clarity. Happy to discuss. Take care. Look at our website www.ybyte.in, because we have lots of such content where we analyze things in detail and learn programming in a fun manner. Take care. Thank you so much. Bye-bye.